Assalamualaikum, my name is Nurul Hazlin Natasha. In this video, I will present my project 2 Inferential Statistic and my case study for this project is about outbreak of Ebola virus. So as an introduction, in year 2014 to 2016, the Ebola virus epidemic was the most widespread outbreak of Ebola virus disease, which causing major loss of life. This outbreak affected several countries worldwide, including Western African countries. And this case study is about to do the statistical analysis on how this Ebola virus epidemic spread worldwide along this period. The dataset for this variable disease, which is fatality case rate, confirmed case rate, probable death rate, country, dates, and other variables were recorded. And next, for the dataset, it's obtained from an online platform called Kaggle to carry out this inferential statistic. The collected dataset was provided the number of Ebola outbreak cases and deaths from 2014 until 2016. The target population is Western African and North American people. So this is a few variables that have been shortlisted to be measured in this project. So for the first variable is number of confirmed cases will be measured to determine the differences of mean for this variable in 2014 and 2015 for hypothesis testing to sample. For the number of suspected case and confirmed case, it will be analyzed in correlation and regression tests. The third one, the number of confirmed deaths and year are selected to be analyzed the dependency using chi-square test of independence. And number of suspected deaths variable will be chosen to measure the proportion for 3 years in goodness of fit test. And the last one is number of confirmed deaths to determine the difference between the mean of this variable for 2014, 2015, and 16 for ANOVA test. Next, I will explain the result for the data analysis. For the first test is hypothesis testing to sample. So two random sample of 100 and 110 were selected, and the variance are assumed to be not equal since there are no reason to predict that the data having the same variance. The null hypothesis for this test is the mean of number of confirmed cases in 2014 is equal with the mean of number of confirmed cases in 2015. While the alternative hypothesis is the mean in 2014 is not equal with the mean in 2015. So in this test, I use alpha 0.05, and from the R calculations, I can get the T statistic is negative 2.835885, which is less than with the T critical value, which is negative 1.98. So I can conclude that the null hypothesis is rejected, and there is enough evidence to conclude that the mean of number of confirmed cases in 2014 is different from the mean of number of confirmed cases in 2015. Next is correlation test. For correlation test, a sample of 30 days was selected, and the null hypothesis for this test is there is no linear correlation between number of suspected case and the number of confirmed case. While for the alternative hypothesis is the linear correlation exists between number of suspected case and number of confirmed case. So from the R calculation, I get p-value is p-value is 1.021 times 10 power of negative 8, which is less than with the significant level that I use in this test. So I can conclude that the null hypothesis is rejected. So there is enough evidence to conclude that the linear correlation exists between number of suspected case and number of confirmed case, with correlation coefficient is positive 0.834159 at alpha 0.05. This is the scatter plot for correlation test. So from the graph, it shows that as the number of suspected case increase, so the number of case will increase too. And then the correlation coefficient value, which is R, is equal positive 0.834259, and it's clearly show that it has positive strong linear relationship between these two variables. For the third test is regression test. So regression is test I take the variable same as the correlation test, and a sample of the t days also was selected. So the dependent variable y for this test is the number of confirmed cases, and the independent variable x is number of suspected cases. So the null hypothesis for this test is the slope is equal to 0, while the alternative is slope is not equal to 0. So from the R calculation, I can get this p value is this value, and t statistic is 8.005. So since the p value is less than with the significant level, so the null hypothesis will be rejected. Therefore, they have enough evidence to conclude that the number of suspected case will affect the number of confirmed case, with slope of this model is 0.9235. Next is the scatter plot for regression test. So from the regression graph, it's shown in a positive strong linear relationship with an equation of y equal to 228.1237 plus 0.9235x. So the value of the intersection coefficient is 228.1237, that indicate the number of confirmed cases of Ebola when there are no suspected cases. So the value of slope coefficient, it's get 0.9235, which is indicate the estimated change in average value, which increasing the number of confirmed cases when there is suspected case of Ebola. So the coefficient of determination, which is R square in this relationship, is 0.834259, which is close to 1. So it can be considered as a strong relationship. Next test is chi-square test of independence. So for this test, a random sample of 2 countries was selected, and the null hypothesis is the number of confirmed deaths of Ebola for each country is independent by year, while the alternative is the number of confirmed deaths of Ebola for each country it's not independent by year. So from the R calculation, the chi-square value is 762.38, while the critical value is 5.99. So since the x square statistic is bigger than x square critical value, so the null hypothesis will be rejected. Therefore, there is enough evidence to conclude that the number of confirmed deaths of Ebola for each country is not independent by year. So for the next test is goodness of fit test. So this test is to determine the proportion for the number of suspect deaths for 3 years. So the probabilities are assumed to be equal, since there are no reason to predict that the probability or the frequency have any claim value. So the null hypothesis is P1 equal to P2 equal to P3, which is P is indicate that the number of suspected death for each year, and the alternative hypothesis is at least one of the three probabilities is different from the others. So in this test, I use significant level 0.05 also. So since p-value is less than with the alpha, so the null hypothesis will be rejected. Therefore, they have enough evidence to conclude that at least one of the three probabilities is different from the others. So the sum of the suspected death in 2014 is 1,110. In 2015 is 34764 and 158 in 2016. So based on this calculated sum and the conclusion that I get from the test, it's shown that the Ebola outbreak spread that can lead to death are more in 2015 compared to 2014 and 2016. Okay, for the last test is ANOVA test. So a random sample of 3 countries was selected, and the null hypothesis is mu1 equal to mu2 equal to mu3, which is mu indicate the number of indicate the mean of number of confirmed death in each year, while the alternative hypothesis is at least one of the mean is different. So since the p-value is less than with the alpha 0.05, the null hypothesis will be rejected. So they have enough evidence to conclude that at least one of the mean is different. Thus, it also shown at different year it have different mean of number of confirmed deaths of Ebola. Lastly, for the conclusion, from this project, I learned on how to analyze the data from the secondary data set. I need to identify the suitable variables to carry out all the tests. And for the correlation test, I have to do the data processing since I only need a few samples for 2 variables to be analyzed. Based on all the findings through this analysis, a few conclusions can be made. Firstly, the most widespread transmission of Ebola in West Africa region occurred in year 2015. Secondly, I found that the mean of number of confirmed cases in 2014 is different from the mean of number of confirmed cases in 2015. And next, the results shown a positive trend between number of suspected cases and number of confirmed cases. Lastly, the mean of number of confirmed deaths are not equal for each year since the number of confirmed deaths in 2015 are more compared to 2014 and 2016. So that's all from me. Thank you.